Hi, today we're going to be reading chapter 7 in Unit 5, and it is called Earth's Powerful Forces of Change. Our big question is, how do weathering and erosion continually reshape Earth's surface? We are going to be focusing on identifying, defining, and providing examples of weathering and erosion and how they reshape Earth's surface. All right, I'm going to start reading on page 62. Please make sure that you follow along. Have you ever dodged a pothole while riding your bike? Or skidded on grit that rain had washed in your path? Potholes and grit might seem like little more than bike riding hazards, yet they are evidence of two powerful forces at work. I lost my place. Weathering and erosion, as you read in chapter 6, are processes that drive the rock cycle. They break down rock into sediments and then move them to new locations. Together, weathering and erosion are slowly but steadily reshaping Earth's surface. They are changing everything from the streets and neighborhoods and towns to the world's tallest mountains. Weathering at work. Weathering breaks rocks into smaller pieces. A little break. As we've learned, weathering can be where it breaks the rocks down. It can be actual weather, rain, hail. It can be ice, where the water gets in the cracks of the rocks and breaks them apart. But it can also be people that break up rocks or just by walking on them breaks it. And we'll learn some more in here. But weathering sounds like it's only weather, and it can be other things too. Okay, some of these tiny pieces together combine with once living material to form topsoil. So topsoil is the soil on top, and it has a lot of sediments in it. Other pieces of small rock collect as sediments. This breakdown of rocks happens as they interact with air, water, and living things. There are two basic types of weathering: physical weathering and chemical weathering. Physical weathering, on page 63, breaks big rocks into smaller ones without changing the minerals. And that is the big difference between physical rock weathering. It's where something physically happens, they break because of people or animals. But chemical weathering changes the minerals of the rock. So if the rock just breaks and crumbles, physical. If the minerals change due to a chemical, it's chemical weathering. All right, back to reading on page 63. Second sentence, first paragraph. Widely swinging temperatures can cause physical weathering. For example, rocks in a desert bake during the day beneath the sun's scorching heat. As rocks get hot, they expand. At night, temperatures in the desert fall. As rocks cool down, they contract or shrink slightly. Expand, contract, expand, contract. This endless cycle gradually causes the rock's outer layer to crumble or flake off. And that is physical weathering. Water also causes physical weathering. Water seeps into tiny cracks in rocks. If temperatures drop below freezing, the water turns to ice. Water expands as it freezes, pushing outward and enlarging the rocks. Geologists call this process ice wedging. Each time the water freezes, it opens the crack a little wider. Eventually, the rock splits apart. Ice wedging is what makes potholes in streets too. So, if you're driving and you go like that because there's a pothole, kind of a hole where the street has broken down, ice causes that, and ice wedging. And that is, if you know what a wedge is, looks like this. Some people say that Mrs. Killinger has one in her door to keep it open, a wooden wedge. Well, that's kind of what the ice does. It gets in there and then it expands. And then more gets in there and it expands more, and it eventually breaks the rock apart. All right, last paragraph on 63. Plants and animals also cause rocks to weather. Tree roots squeeze into cracks in rocks. As the roots grow, they act like wedges, forcing the cracks wider and wider. Eventually, the rocks break apart. Badgers, chipmunks, and other animals burrow into cliffs and hillsides like tiny bulldozers. As they dig or tunnel into the ground, they push buried rocks to the surface where most weathering takes place. And that makes sense that the rocks on top of the ground is where most weathering is going to take place. All right, let's turn to 64. Chemical weathering. Chemical weathering breaks down rocks by changing the minerals they contain. Rain is a powerful chemical weathering force. As rain falls, you don't think about this, but it mixes with the gas carbon dioxide in the air. The result is acid rain. Acid rain, this is not all rain, but acid rain is strong enough to dissolve some minerals in rocks. Acid rain, maybe it is all rain. I'll look into that. Acid rain very slowly carves some rocks. Oh, I'm sorry. Sorry. The result is acid rain. Acid rain is strong enough to dissolve some minerals in rocks. Once dissolved, the minerals easily wash away, weakening the rock. Acid rain very slowly carves some rocks into different shapes, like the ones in the picture. It gradually erases the letters on old gravestones. I love to look in graveyards at the really old gravestones, but some of them are very hard to read because I guess the acid rain has weakened the minerals, changed the minerals of the rock, weakened them, and they've washed away. And blurs faces of stone statues. It eats away at the outside of ancient and even modern buildings, where rain seeps into the ground. Carbonic acid causes weathering of buried rocks as well. So even the ones that are buried will be affected by acid rain. Over long periods of time, this often unobserved weathering creates caves deep underground. That is interesting. I often wondered, how are caves deep underground created? I didn't know it was by seeping acid rain into the earth. 65. Another gas in the air, oxygen, causes chemical weathering in rocks. With a little help from water, oxygen reacts with iron-containing minerals. The reaction changes the minerals, making the rocks brittle and crumbly, and turning them a rust color. I've seen some rocks that, part of them are rust color, and I always wondered about that. I guess it's from the rain combining with the oxygen that we breathe, and it changes the minerals in the rocks. Some plants release rock weathering substances. Take a peek under a patch of moss growing on a rock, and you'll see little pits in the rock's surface. I have seen that before, but I didn't know that the plant had changed the minerals in the rock. That is so interesting. Acid from the moss plant caused the damage. As a result of all weathering, rocks are broken down into smaller pieces and ultimately into sediments. Erosion is what gets those sediments moving. Okay, the caption for the picture says towering rock formations created by chemical weathering rise straight up out of the ground near Kunming, the capital of China's Yunnan province. Some formations are as tall as 10-story buildings. The Chinese call this place Shilin, or the stone forest. That is beautiful. All right, I want you to stop and think how physical weathering changes rocks. All right, hopefully you thought about changes in temperature, how if like in a desert it gets hot so they expand, cold so it contracts, and how that over and over causes it to flake off or break. If water, the ice wedging, maybe if the water gets in the cracks and it freezes and then thaws and then freezes and it keeps getting bigger and bigger, it's going to cause that to break. And roots of plants can squeeze into the cracks. Animals burrowing, can cause that. All of those things are physical weathering. All right. I want you to also think of chemical weathering. That is where the chemicals actually change the minerals of the rock. So if that rainwater mixes with chemicals in the air, like carbon dioxide that we breathe out or oxygen that we breathe in, it can change their shape and color. Also, some plants release chemicals that change the color of rocks. That image is so beautiful. Okay, we're going to keep reading on to page 66. Sediments on the move. That means erosion. Geologists describe erosion as any process or force that moves sediments to new locations. Wind, flowing water, moving ice, and gravity all transport sediments from place to place. These forces are primarily causes of erosion. Have you ever stood on a sandy beach on a windy day? Did you notice that gusts of wind sent sand flying past? When air moves quickly across the ground, it picks up sediments and carries them away. Powerful winds can carry sediments for hundreds, even thousands of miles. I've experienced that on the playground when it's super windy, sand, little rocks will hit you and you're just like, ow. That is erosion when it's taking those sediments. On the windy beach, this is page 66, the third paragraph. Did your skin sting as it was struck by blowing sand? Yes. Wind carrying sediments can act like a sand blasting machine to wear away rocks in its path. When wind-driven sand hits rocks, it chips off tiny pieces. The wind then whisks the pieces away. Over time, this form of weathering can polish rock surfaces or pepper them with tiny holes. Pepper means like sprinkle them. not salt and pepper. It can shape huge blocks of rock into delicate stone arches and lofty towers. Weathering and wind erosion can also leave massive boulders balanced on slim supports. Have you ever seen wind-carved rocks like this? I've never seen one that big. This one is a delicate arch in Arches National Park in Utah. That is gorgeous. As wind slows down, the sediment it carries fall back to earth. They are deposited, put down, on land or in water. Where wind deposits sediments regularly, layers of sediments slowly build up. And over time, those layers may be transformed into sedimentary rock. All right, so how does wind cause weathering and erosion? Well, the wind picks up the sediment, carries them away, and then as it's blowing against other rocks, breaking it apart. That's weathering. And then blowing it, and then it's going to drop it down, deposit it. How are sediments and sedimentary rocks related? Think. Well, we know sedimentary rocks are made of sediments. So over time, as the sediments are blown, dropped, compacted, cemented, layer by layer, they turn into sedimentary rocks. All right, let's go to the next page. Okay, the caption for that amazing picture, it says, glaciers like this one in Alaska are powerful forces that can cause erosion. That is just an amazing picture. So, heading downstream, page 69. Like wind, water also causes erosion. We've talked about how powerful water can be. The tug of gravity pulls sediments out of wind and water, pulls it down. Flowing water picks up sediment and carries them downhill to a new location. The summer rains can wash fine sediments onto sidewalks and into gutters. A rushing mountain stream can sweep small stones into a valley. A flooded river can surge along with enough force to move large rocks many miles downstream. We've talked about how powerful water is and how we had that flood here and how it just took huge chunks of land, large rocks, trees. I mean, water is one of the most powerful forces we have. As moving water slows, sediments sink to the bottom of a river or stream. Back to that flood, it carried sand and deposited it on a lot of people's farmlands, on people's yards. I mean, people had sand everywhere because when the flood came, it brought sand. And it was beautiful sand. I suppose, I don't know where it came from, but up the hill, sand, but it was really hard for farmers to have all this sand deposited on their farm ground. So that caused a problem, but it was interesting to see how the erosion with that flood brought all that sand and deposited it here. Okay. You're on the second paragraph on page 69. As moving water slows, sediments sink to the bottom of the stream. The heaviest sediments are the first to be deposited. The finest sediments, like the sand, it was so just soft, tiny sand, are the last. Layers of sediments accumulate at the mouths of rivers and on the bottoms of lakes. Vast layers of sediment are also deposited on the ocean floor over long periods of time. Like wind-deposited sediments, those laid down by water may someday be transformed into sedimentary rock. Water doesn't have to be in its liquid state to erode sediments. Glaciers are enormous masses of ice found in polar regions and near the tops of tall mountains. Although ice is solid, glaciers do move. They flow very, very slowly downhill. A countless tons of ice creep over land or down mountains. I can't even imagine. Mountainsides, they push, drag, and carry eroded sediments along. Moving glaciers also create sediments as they grind against rocks beside or below them. Glaciers are such powerful forces that they can carve huge U-shaped valleys through mountain ranges. Just like that. Carved by a glacier. When glaciers melt, they deposit the sediments they have been carrying. About 20,000 years ago, glaciers covered large parts of North America, Europe, and Asia. As the climate warmed, the glaciers melted and retreated northward. They left behind massive deposits of sand, gravel, and silt, along with collections of rocks and boulders. You can still see the deposits as hills, mounds, and ridges on the landscape. That is amazing, isn't it? So I want you to think about how water causes erosion. So think for just a little bit. Okay, so flowing water picks up sediments and carries them downhill to new locations. So remember, erosion is the moving of sediments. Based on the information that we've learned from our text, how does the amount of flowing water affect the type of sediments that are eroded? Hopefully you're thinking the more moving water there is, the larger the sediments and rocks that are moved. A summer rain does not include much water, so the sediment it moves are small. A rushing mountain stream, however, has much more water, and so it moves a lot faster, so it can move smaller. It can move smaller stones, bigger than the rain can move to the valley. Say at the bottom of a mountain, like if it's a stream coming down a mountain. A flooded river that's overflowing, like the one we had here, is very fast moving. And so it's strong enough to move large rocks down the river. Then think of glaciers. It is still water, but it's in a frozen state. They cause a lot of weathering because they scrape and grind against rocks beside them and below them, and they move more slowly downhill. They push, drag, and carry eroded sediments along. So, go on to the next pages, 70 and 71. That picture is the Grand Canyon, and that was formed by weathering and erosion. Isn't that beautiful? Weathering, erosion, and time. Weathering and erosion work slowly. It takes a long time to see their effects. Given time, these processes reshape Earth's surface on a scale so large it's impossible to grasp. For example, the Grand Canyon in the southwestern United States did not exist when dinosaurs roamed North America. It was just flat land. Maybe a hill or something. It did not have these canyons. Wind, rain, and the Colorado River slowly created it. These forces cut and shaped the landscape into what is today one of the world's largest canyons. So think about that. The Colorado River, which is still part of it, still a river, and the wind and the rain created that beautiful canyon. Millions of years ago, the Appalachian Mountains in eastern North America were a towering mountain range. The highest peaks may have been more than 20,000 feet above sea level. Weathering and erosion gradually wore the Appalachians down. Their highest point to date is just 6,684 feet high. So from 20,000 to 6,000. As permanent as mountains seem, weathering and erosion inevitably change them. Even Earth's tallest peaks, Everest in Asia, Aconcagua in South America, Africa's Kilimanjaro, and Europe's Mont Blanc won't last. They will eventually be worn down by these endless geographical processes. But don't worry, other geographical processes are creating new mountains to take their place. So, hopefully you're thinking, wow, I didn't realize how weathering and erosion were changing our Earth. That over time, they've even worn down great high mountains, and that they will continue to reshape our Earth every single day. All right, I hope you enjoyed this chapter.